Good day, sir. I am Peralta.
And I'm Jehu Ombion.
And I am Argie Villaluz of Bachelor of Science in Civil Engineering. And this study entitled Assessment of Landslide Susceptibility, a case study of Carabao Mountain in Baguio City, study by Maria Cecilia R. Paringit, Miller D.L. Cutura, Eleazar H. Santiago, and Mary Ann Q. Adajar, and published by International Journal of Geomate on July 2020.
Background of the study. The city of Baguio is popularly known as the summer capital of the Philippines. It is a highly urbanized city in the northern part of Luzon in the Philippines. Baguio City is nestled on Cordillera Mountain Range with elevation ranging from 900 to 1,600 meters above sea level. Due to its geographical location in a very high plateau, Baguio is commonly exposed to storms and heavy rainfalls. With such, a landslide is very prevalent in the city. Landslide is a hazard that causes properties to massive damage and sometimes the cause of life loss. Landslide may be induced or triggered by other natural activities such as immense rain or earthquake. During storm or heavy rainfall, as well as during earthquakes, landslides are prevalent to the city of Baguio, which causes the thoroughfare to stop the operations and can cause the different properties. Landslide is one of the causes of deaths in the city during calamities. The susceptibility to a landslide of area is high due to the formation of the terrain, type of soil, as well as changes in land use. Lack of information and warning system regarding rainfall puts a challenge to a fight to decrease casualties. Susceptibility maps that may be used as a tool for predicting the movement of the soil or warning system implementation will be needed. And according to the City Disaster Risk Reduction and Management Council, or CDRRMC of the City of Baguio, here are the list of the reported landslides in the city. Statement of the problem. First, this study investigates if a slope is susceptible to failure using parameters related to slope stability and will incorporate the additional assessment tools which will improve the existing susceptible map. And second, this study is geared to create an assessment tool for rainfall-induced landslide and identify the landslide susceptible area at Baguio City for planning and preparedness.
The study employed descriptive and analytical research. Descriptive research was used to describe, classify, measure, and compare the present state of the area for the identification of scores for the different assessment tools. Analytical research was used to analyze the current situation of the area and make a critical evaluation as to the susceptibility of the area to landslide based on the assessment tools. Population and local of the study. Baguio City occupies about 57 square kilometers of hilly land in the southwestern portion of the Cordillera Central Mountain Range in northern Luzon in the Philippines. The weather follows the typical Philippine seasons: dry season from October to May and wet season from June to September. The research covered north-left portion of the central business district of the city of Baguio. Since these areas are high density and prone to landslide as per City Disaster Risk Reduction Management Council of Baguio City as shown in Figure 2. This area is popular by its name as the Carabao Mountain, which was intended to be the pasture land of the Camdas clan. The portions of the Carabao Mountain considered are Quirino Hill and Benguet area, which is limited by the yellow boundaries. As of 2015, census as per Philippine Statistic Authority, Cordillera Baguio has a population of 345,000, which is about 20% of the region's population. The population density during that time is about 6,005 persons per square kilometer. The average annual population growth rate is 2.36. The study evaluated the state of the slope with the aid of computer program and incorporating the effects of triggering factors. Figure 3 summarizes the research design of the study. The geotechnical data was requested from BIP Steadfast Grounds Inc. The topographic map was issued by the City Planning and Development Office. Data gathering. The researcher was going to gather soil properties, landslide statistic, and topographic map. Stability analysis, which is the determination of factor of safety. Generation and application of additional factors, landslide use and loading factors, and also the soil saturation factor. Next is the landslide susceptibility, the level base of general factor of safety. Next is landslide susceptibility map, rainfall precipitation and identification for warning system, and the conclusion and recommendation. In Table 3, it shows the susceptibility levels. Factor of safety, 1.5 is less than 2 factor of safety. Color coding is yellow, which means it has a low susceptible level. Another one is 1 is less than 2 factor of safety and less than to 1.5, which is the color coding of orange, and it has a moderate susceptible level. And factor of safety is less than to 1, and the color coding is red. It signifies high susceptible level. Land use assessment additive factor. The 3 different land use factors that are considered in the study are vegetation, which are the open space, and with trees, road network, and settlement, which is the buildings. For the generation of the factor, a 10-meter tributary width for load distribution was considered, shown in Table 4 as factor use.
The Table 4 shows distributive load for the land use impact and land use tool of vegetation, road network, and settlement, while the Figure 4 shows the color coding based on the land use.
Saturation of soil assessment additive factor. The saturation of soil additive was based on the degree of saturation of the soil, with the preliminary values of soil parameters and computing the values of boiled ratio and degree of saturation. The value of soil unit weight with different saturation was calculated, which must be higher than the saturation level of the soil being considered, that is about 70%. The factor for the degree saturation is given in Table 5. Degree of saturation, 70%, which is equivalent of 0 saturation unit weight, and 80%, which has a negative 0.018. 90% of degree saturation has an equivalent of negative 0.036, and the 100% degree of saturation has the equivalent of negative 0.054. General factor of safety. The color coding established in Table 4 was used for the easier construction of maps. Majority of the area is safe, but as the saturation increases, some are already exposed to danger since the value of the lowest factor of safety for saturation values of 70%, 80%, 90%, and 100% are 1.061, 1.043, 1.025, and 1.0077 respectively. The critical area, or the area with the lowest factor of safety, was highlighted in Figure 6, is at Barangay Benguet, Baguio City. Portions that are close to value of 1 are already on the verge of failure. Necessary precautions and engineering interventions must be accounted for.
For the conclusion, this study was intended to predict the possible role of external factors such as land use
and saturation of soil due to rainfall on the factor of safety of slopes, which is the deterministic factor of stability of earth slopes. Based on the results, land use loading and saturation of soil reduce the shear strength of the soil, thus reducing the factor of safety of the soil. Meron tayong figure dito. Ito po yung map ng Baguio City. So, may papansin natin yung yellow part, yan po yung low susceptibility. And the orange na nakikita natin, orange part is the moderate susceptibility. Then the red one, yung nakikita natin yung red na part, then yan naman po yung high susceptibility. The area that is close to the critical factor of safety, which is 1, is the residential area located at Barangay Benguet, Baguio City, as presented in the figure in previous slides, which is highlighted in the red box. Thus, the addition of loading on that area would be risky. The residential areas at Barangay Quirino Hill, Baguio City, highlighted in the blue box, are already the ideal factor of safety, which is 1.5. This implies the possibility of a landslide in the area, especially if the load in the area is higher than the assumed values. The map generated can be used as a guide in identifying the areas that are susceptible to a landslide. For the recommendation, this landslide susceptibility map shall be used together with a warning system for necessary action during immense rainfall. And the warning system of Pag-asa, which is red warning, will be adapted for precipitation, which is 40 mm per hour and above. At this level, upon the release of the Pag-asa warning, the preceptive action will be an immediate evacuation rendered by the concerned government bodies such as CDRR-MC. That's all for our report. Thank you for listening. Stay safe and God bless.
Thank you for listening. Have a great day and stay safe.